Very funny thing is that opportunities don't come very often. They come far and few. When I look back on all the things I have done, it's an incredible work that have uploaded so many topics in the playlist. I hope you may marvel at these opportunities that come your way. Please go through the playlist, analyze them, and learn through them. And now, today's topic is integration using residues. So, in this video, I am going to take the integral of the type, that is integral minus infinity to plus infinity e power imx f of x into dx. Now I am going to evaluate integral 0 to infinity x into sin mx by x power 4 plus 16 into dx using this residue theorem. So here this is the contour. So the contour is nothing but it is through the real axis minus r to plus r, and it is a semicircle with center 0 and radius r. So this is the closed contour which I am going to take here. Now in order to solve this, so we have to consider the integral. So this is integral c f of z dz is nothing but x sine mx by x power 4 plus 16 into dx. Now see here, see what is C here? C is a contour. So this is the contour consisting of a semicircle CR of radius R bounded the diameter minus R and plus R. So this is the diameter minus R plus R, and this is through the real axis minus r to plus r, and again through the semicircle with center 0 and the radius r. So this is the contour which I am going to take, that is mod z is equal to r. And now we know that sin mx is nothing but the imaginary part of e power imz. So imz, so e power I theta is nothing but cos theta plus I sin theta. So here sin theta represents the imaginary part. So as we have sin mx in the given question, so I am taking the imaginary part and I am considering this f of z as z into e power imz by, this is z power 4 plus 16. Now in order to use the residue theorem, first of all I have to find the poles. As you know that if the function is given, how to find the poles? So in order to find the poles, we have to equate this denominator to 0. The poles of f of z are given by z power 4 plus 16 is equal to 0. So z power 4 is minus 16, and see here 16 times of minus 1 can be written as minus 1 plus I times 0. This is the real part and this is the imaginary part. So minus 1 can be written as cos 180 degrees and 0 can be written as sin 180 degrees. See here z power 4 is equal to 16 can be written as 2 power 4, and this is in general can be written as cos of 2n plus 1 pi plus I times of sin 2n plus 1 into pi. Clear? And now I need the value of z. So this power 4, if it goes to other side, it rises to 1 by 4. So 1/4 of this term. That is, if I cancel this one, so this will be 2, and if I bring, that is pi by 4, and this becomes pi by 4. So I need to put the values of n as 0, 1, 2 and 3. So if I keep n is equal to 0 in this term, then this will be, if I keep 0 here, this will be 2 times of cos pi by 4 plus I times of sine pi by 4. As you know that pi by 4 is nothing but 45 degrees. So this is nothing but 45 degrees, and this is also 45 degrees. So cos 45 degrees is 1 by root 2 and sine 45 degrees is 1 by root 2. Clearly 2 can be written as root 2 into root 2. So if I take root 2 as LCM and cancel, so z1 value, the first pole here is root 2. If I send root 2 to inside, so this will be root 2 plus I into root 2. So this is pole number 1. And next one, if I keep n is equal to 1 in the function, so if I keep n is equal to 1 here, if I keep 1 here, this will be 2 plus 1 3, and if I keep 1 here, this will be 2 plus 1 3. So if I keep n is equal to 1, z2 becomes 2 times of cos 3 pi by 4 plus I times of 3 pi by 4. So how to solve this? So this can be written as pi minus pi by 4. See, if you take 4 LCM, this is 4 pi minus pi, this will be 3 pi. So here also, if I take 4 LCM, this will be 4 pi minus 4. So 180 minus theta. So what will be 180 minus theta? So here 180 minus theta. So cos 180 minus theta is nothing but here sin theta, cosecant theta are positive and rest are negative. And therefore this will be minus cos theta, and here sin is a positive value and therefore this is positive. That is I times of sin pi by 4. As you know that sin pi by 4 is 45 degrees this will be minus 1 by root 2 and this is plus 1 by root 2. So if I take root 2 as LCM and if I write 2 as root 2 into root 2 and if I cancel root 2, this will be minus root 2 plus I times of plus root 2. So this is our pole number 2. And next thing here is, in this if I keep n is equal to 2. So in this if I keep n is equal to 2, so 2 2s are 4 plus 1 5. Here if I keep n is equal to 2, this will be 2 2s are 4 plus 1 5. So this will become 2 times of cos 5 pi by 4 plus I sin 5 pi by 4. How to write this one? So this can be written as 180 plus theta, that is pi plus pi by 4. So if I take 4 LCM, this will be 4 pi plus pi, which is equal to 5 pi by 4, and this can be written as pi plus pi by 4. So here if you see, this is 180 plus theta. So this is 180 plus theta. In this, tan and cot are positive, rest are all negative. So there is no tan and cot. Therefore, this is a negative value and this is a negative value. This will be minus cos in place of theta pi by 4, and this is minus a sine. This is pi by 4. Pi by 4 value is nothing but 45 degrees, and this is 2 times of minus 1 by root 2 minus I times of 1 by root 2. 2 can be written as root 2 into root 2, and if I take root 2 LCM, this is minus 1 minus I. So if I cancel root 2 for one time and send root 2 inside, this will be minus root 2 minus I times of root 2. This is our third pole. And next thing here is, after keeping n is equal to 2, what I have to keep? N is equal to 3. In the same term, if I keep n is equal to 3 here, this will be 3 2s are 6 plus 1 7. Z4 becomes 2 times of cos 7 pi by 4 plus I times of sin 7 pi by 4. 7 pi by 4 can be written as 2 pi minus pi by 4. This is 360 minus theta. So if you go with 360 minus theta, here cos theta and secant theta are positive, rest are all negative. So cos is positive value. Therefore, this is cos theta. In place of theta, we have pi by 4 and rest are negative. This will be minus I sin pi by 4. So pi by 4 is nothing but 1 by root 2, and this is minus 1 by root 2. So root 2 can be written as root 2 into root 2. After cancelling, we got this as a fourth pole. See here. So for n is equal to 1, we got this one, 2, 3 and 4. So these are all the values. So these are all the points which we can write as root 2 comma root 2, and this one is minus root 2 2, and this is minus root 2, and this is minus root 2, and this is root 2 minus root 2. And now after finding all these poles, so what we have to do? So we have to check whether these poles are inside the contour or on the contour or outside the contour. So what is the contour here? So the first one here is, the first pole is 2 times of, this can be written as cos theta plus I sin theta can be written as e power I theta. So for this, the pole values are root 2 into root 2. For Z2, this is 2 times of minus root 2 and root 2. And Z3, this can be written as 2 times of e power I 5 pi by 4. And this is minus root 2 and this is minus root 2. For Z4, this is 2 times of e power I 7 pi by 4. This is root 2 minus root 2. Now this is Z1, Z2, Z3 and Z4. Now we have to plot in this contour and we have to show whether they are inside, outside or on the given contour. See here, this is 1. So obviously this will be 1 and this will be 1 and this is minus 1. So if you see, observe this one, this will be minus I and this value is plus I. Clear? So after that, what is root 2 value? Root 2 value is nothing but 1.4 something, 1.414. So 1.4, so it will be here. So this is root 2 here. So this value will be minus root 2, and here if I extend this one, this is minus root 2 and this value here is plus root 2. Clear? This value will be plus root 2. So root 2 comma root 2. So root 2 comma root 2 will be here. So this is inside. Root 2 comma root 2 is within the contour, and this is minus root 2 and plus root 2. So here this value is also inside. So the first one is Z1 is equal to 2 times of e power, this is I pi by 4, and this value is Z1 is equal to 2 times of e power I 3 pi by 4. And here if you see minus root 2, this is minus root 2. So here this value is Z3 value here is 2 times of e power I 5 pi by 4. So this is Z3. And next one I pi by 4. This is root 2 and minus root 2. So this is root 2 and this is minus root 2. Here Z value is 2 times of e power I 7 pi by 4. So if you observe this one, these two are outside the given contour, and these two are inside the given contour. So which are inside? That is 2 times of e power I pi by 4, and next one 2 times of e power I 3 pi by 4 are within the given contour. These two are within the contour and these two are outside the given contour. So of these poles, only two poles, that is Z1 is 2 times of e power I pi by 4, and Z2 2 times of e power I 3 pi by 4 are within the given contour. So for using the residue theorem, what we have to do? So we have to find out the residues for the interior poles. So here, what are the interior poles here? The interior poles are nothing but these two, the first one and the second one, Z1. So here Z1 is equal to 2 times of e power, this is I pi by 4, and next one Z2 is equal to 2 times I power, this is I into 3 pi by 4. Now I am going to find out the residue value. So how to find this residue value? So what is the function here? The function f of z is equal to, so f of z, the function here, this value is z into e power imz by, here this is z power 4 plus 16. Now we have to find out the residue value. For finding the residue value, what we have to do? That is residue of f of z at point z is equal to, this is z1. The first value is z1 is equal to, this is limit z tends to z1, this is z minus z1 into f of z is the formulae. So here in this, if I keep, this is limit z tends to z1, this is z minus z1 into, what is our f of z? F of z value is nothing but z into e power imz by, this is z power 4 plus 16. If I straight away keep z1 in both the numerator as well as denominator, this will be 0 by 0. So now we have to apply L'Hospital's rule. L'Hospital's rule. So in this L'Hospital's rule, what we have to do? So we have to make a derivative for the numerator as well as denominator, and again we have to substitute z is equal to z1. So for applying L'Hospital's rule, I am considering this as u and this term as v. So this as v and this as u. So as you know that I am making a derivative, I am leaving u as it is, that is z minus z1, and I am making a derivative for this one. For z, this is 1 e power imz, and next one here is, after making a derivative for this, and next one I am leaving z here. So this will be e power imz. For z this is 1, what remains here? Im remains. So after making a derivative, again I have to leave this one, that is z into e power imz I have to leave, and I have to make a derivative which is equal to 1 by, if I make a derivative, this will be 4z cube, and this value is 0. And now what we have to do? So we have to apply z is equal to z1 here. So if I apply z is equal to z1 here, this will be z1 minus z1, and this is e power im z1 plus this is z1 im into e power im z1 plus this value is z1 into e power im z1 by, this is 4 times of z1 cube. So this is z1 minus z1, 0 into anything is 0, and what remains here? So this is z1 into e power im z1 by 4 times of z1 cube. So if I cancel this for one time, square remains. Therefore, this is residue of f of z at point z is equal to z1. Formula here is e power im z1 by, this is 4z1 square. So please remember this one. So this is also so important. So in this, what is our m1? So what is our z1? See here. In this, I am keeping z1 value and z2 value, so that I will be getting the two residue values. So what is z1 here? So z1 is nothing but 2 times of, see here, z1 is nothing but 2 times of e power I pi by 4. Clear? And next in this, if I keep z1 here, the residue value I am getting, this is residue of f of z at point z is equal to 2 times of e power I pi by 4 is very clear as e power im Z1 is nothing but I pi by 4 by 4 times of, what is Z1 here? This is 2 times of e power I pi by 4. This value is whole square. Clear? This value is whole square. So this value I have written this as, for this, what is the value here? Just now I found. So this is nothing but, this can be written as root 2 plus I root 2. So this value after calculating I got this as root 2 plus I into root 2. So e power I pi by 4 can be written as Z1. In place of Z1 if I write this one, this is e power I m Z1 by, this is 4 into Z1 square. So Z1 is equal to, this is root 2 plus I root 2. If I substitute this one, this will be root 2 plus I into root 2 by 4 times of, this is root 2 plus I times of root 2 whole square. So this is, if I multiply this one, this is I m root 2 into, this is I square, this is minus m, this is root 2 by, if I take root 2 common, square with square, this will be 2 times of 1 plus I whole square. So this value is e power I m root 2, and this is e power minus m root 2 by, this is 8 times of a square plus b square plus this is 2ab. So if I cancel these two, and e power I theta can be written as, this is cos theta plus I sin theta. So this is cos theta. In place of theta we have m root 2 plus I times of sin, this is m root 2 into, this is e power minus m root 2 by, so this value is 16 into I. Clear? And next one here is, if I multiply each and every term here, so there is I here, so I am multiplying and dividing with I. So here if I multiply with I and again divide with I, see what happens here. This will be I times of, this is cos m root 2 plus this value is a sin m root 2 into e power minus m root 2 by, so this is I square, this is minus 16. I square value is very clear. I into I square. So we have I square value as minus 1. So this value we got as minus 1. And this is residue of f of z. So this value is nothing but a residue of f of z at point z is equal to z1. The first thing here is minus I by 16 times of, this is cos m root 2 plus, see here, this is cos m root 2 plus, so this is I here, plus I times of sin m root 2 into e power minus m root 2. So this is our first value here. So this value is the residue value for the interior pole z is equal to 1. So please remember this one. And next interior pole here is Z2. So here Z2 value is nothing but, the next interior pole here will be Z2. So what is our Z2 value? Z2 value is nothing but, see here, Z2 is equal to 2 times of e power, this is I 3 pi by 4. So for e power I 3 pi by 4, what will be the value here? So this is minus root 2 plus root 2. Therefore, Z2 value is equal to minus root 2 plus I times of plus root 2. So this is 2. See here, after multiplying with 2 only we got this one. So this is minus root 2 plus I root 2. And now we need the residue value. So the residue value of f of z at the point z is equal to z2 is equal to, see I have shown you a formula here. So which is equal to, so at this, after cancelling and all, so we got the value as e power im. So here this time we have to write z2 and this is 4z2 square. Clear? And now we have a z2 value ready here as, this is residue of f of z at point z2 is equal to, what is our z2? Minus root 2 plus I root 2 is equal to e power I m times of, this is minus root 2 plus I times of root 2 by, this is 4 times of, this is minus root 2 plus I times of root 2 whole square. Whole square. Clear? So this can be written as e power minus I m root 2. So if I multiply this one, dot, this is e power I m, this is root 2 by. So if I take root 2 outside, so this will be 2 after squaring root 2 square. So this will be minus 1 plus I whole square. So this value is nothing but cos of m root 2 minus I sine of, this is m root 2 into, this is e power I m root 2 by, this is 8 times of a plus b whole square is nothing but a square minus b square minus 2ab. If I cancel this one, so what happens? This will be e power I m root 2 into, this is cos m root 2 minus I sine, this is m root 2 by, so this is minus 16 into I minus 16. So this minus, I am writing this in the numerator as I square. So this I am writing as I square e power I m root 2 into, this is cos m root 2 minus I sine, this is m root 2 by, this is a 69. So if I cancel one I, so this will be I by 16 times of e power I m root 2 into, this value is cos m root 2 minus I sine m, this is root 2. So this is nothing but the residue of f of z at the interior pole z is equal to 2. So this is our second value. So this is our second value. So these two are the residue values for the interior poles z1 and z2. So now we have to apply residue theorem. So what does our residue theorem statement states? According to our residue theorem, we have, see here, according to our residue theorem, integral C, this is f of z into dz is nothing but, this is 2 pi I times of sum of the residues, sum of the residues at interior poles, at interior poles. So this will be, see here, this value will be integral C f of z into dz is equal to, so this is integral C f of z into dz value is equal to, this value is 2 pi I times of sum of the residues. See here, the first residue value here is, I am showing you. So for z1, the value here is, it's very clear as, this is minus I by 16 times of, minus I by 16 times of, this is cos m root 2 plus I sine, this is m root 2 into e power minus m root 2. Clear? And the next thing here is the second residue just now we found, that is I by 16 times of, this is, see here, this will be plus I by 16 times of, this value is cos m root 2 minus I sine, this is m root 2 into e power, this is e power m root 2 I into m root 2. Why I here? So if I multiply inside, this will be minus, and if I multiply, this will be I into I square. So here this value is I square here. So this value will be I square, and this is I square here, and therefore this value will be minus 1. So this value is minus 1, and therefore this is minus 1 into, so this value is minus 1. So this is also minus. So this is minus 1 into. So here, if you see this one, this will be 2 pi I times of. So which one I have to take common? That is e power minus m into root 2 if I take common from these two. From these two if I take common, and again what I have to take? I have to take 16 common, and again I have to take I common. If I send I minus inside, this will be minus cos m root 2, and this is minus I sine, this is m root 2, and this is plus, this value is plus cos m root 2, and this is minus I sine, this value is m root 2. M root 2. So now I can cancel these two, and this will be e times of minus m root 2 into, this is 2 pi I square, this is minus negative sign by 16 into minus 2I times of, this is sine m root 2. See here, minus into minus, this value is plus e power minus m root 2, this is 2 pi by 16, and this value is 2I times of, this is sine m root 2. Clear? Now which one I can cancel this one? So I can cancel this 2 and 2. This is 4. For 4 sir. So this I can cancel. 2 2s are 4 and this is 4. So what remains here? This is e power minus m root 2. This is pi I times of, this is sine m root 2 by 4. So this can be written as I times of, this can be written as I times of e power minus m root 2. This is pi by 4 sine of, this value is m root 2. So this is nothing but the total integral f of z into dz according to our function. This is integral c f of z into dz. So what is our integral? So this is total integral is nothing but the contour. This is the closed contour. So from minus r to plus r, and this is along the real axis x axis, and this is y axis, and through this semicircle, so with radius r and center 0, and this is a CR, that is mod z is equal to r. Now this total integral can be split into two types of integrals. The first one is through the real axis, and next one is through the imaginary thing. Imaginary thing, the first thing here is integral c can be split as, integral c can be split as, this is from minus r to plus r, this is from the real axis f of x dx, and this is through the semicircle, that is f of z into dz is equal to, the answer here is I times of e power minus m root 2. This is pi by 4 times of, this is sine m root 2, sine m root 2. As r tends to infinity, see here, as if r tends to infinity here, this will become, so this is minus infinity to plus infinity, f of x is nothing but x into, this is e power imx, so this value is e power imx by, this is x power 4 plus 16 into dx, plus this value becomes 0 as r is tending to 0. So I have given a crystal clear clarity in my previous video. Please go through that as it is a very lengthy video. So this is going to become 0 as r tends to infinity, and this is I into, this is pi by 4 times of e power minus m root 2 into, this is a sine m root 2. Clear? And therefore this can be written as, this is minus infinity to plus infinity x times of, this can be written as, this is cos mx plus I sine mx by, this is x power 4 plus 16 into dx value is equal to I times of, this is pi by 4 e power minus m root 2 into, this is sine m root 2, m root 2. So here this will be, so if I multiply this one, so this will be minus infinity to plus infinity, this is x cos mx by x power 4 plus 16 dx, and next I times of, this is x into, this is sine mx by, this is x power 4 plus 16 dx is equal to, here the real part is 0 and here is the imaginary part, that is e pi by 4 minus e power minus m root 2 into, this is sine m root 2. Now equating the imaginary part on both sides, equating the imaginary parts on both sides. So here these two are the imaginary parts. So if I equate, then this will be integral minus infinity to plus infinity x sine mx by, this is x power 4 plus 16 dx value is equal to, this is pi by 4 times of e power minus m root 2 into sine, this is m root 2, sine m root 2. And therefore, so here is a logic that as it is an even function, see here, This is 0 and this is infinity, this is minus infinity. So the distance from 0 to infinity is same as the distance from 0 to minus infinity. So in order to calculate from minus infinity to plus infinity, it is equal that if you twice calculate from 0 to infinity. So this will be 2 times of, this will be 2 times of 0 to infinity x into, this is sine mx by, this is x power 4 plus a 16 dx value is equal to, this value is pi by 4 times of 5 by 4 times of e power minus m root 2 into sine m root 2. Clear? If I send 2 to other side, this will be integral 0 to infinity x into sine mx by x power 4 plus a 16 dx value is equal to, so this is pi by 8 times of e power minus m root 2 into, this is a sine m root 2. So this is how we have to calculate, and as this video is very lengthy but the most important, I have given a crystal clear clarity on each and every step, so that if you understand you can solve by your own. And in general there is a note here. So this is the famous formulae, that is integral 0 to infinity, that is x sine mx by, see here, make a note of this, x power 4 plus a power 4 dx is equal to, this is pi by, this is 2a square e power minus am by root 2 into, this value is a sine of, this is am by root 2. See here, so this is the formula, so which is very helpful in the competitive exams. And in this, a value is nothing but here 2 power 4, so a value is nothing but 2 power 4. So if it is 3 power 4, you have to keep a is equal to 3 here. If it is like that, keep a values depending upon the question. So this is in general formula. See here, everything is very clear here, and I'll explain you once again. So as this is a very lengthy video, please go through this video for one more time if you don't understand, but don't leave this, as it is also very simple. So I have taken so much of time to give you a clarity. There is no need if you write simply, as you know all the steps here. So this is the question given. So here, this is the contour given, and this is the function we have to take. And after taking the function, so we have to find the poles after equating the denominator. So these are the poles. If you keep n is equal to 0, this is the first pole. If you keep n is equal to 2, this is the second pole. And if you take n is equal to 2, this is the third one, and this is the fourth one, as these are the z1, z2, z3, z4 poles. And we have to check whether these poles are inside or on or within the given contour. For that, so as these are the 4 points, so I have plotted here. So these two are inside, that is e power I pi by 4 and e power I 3 pi by 4 are inside, and these two are outside. So for applying in the residue theorem, we have to find the residues for the interior poles. For the interior poles, first one is z1. So at z1 point, this is the interior pole, and next one for z2, this will be the interior pole for z2. And for z2, and this is the residue value. And after finding the residues, we have to substitute in the residue theorem. So the residue theorem is 2 pi into sum of the residues. So this is the interior pole z1, and this is for the interior pole z2. These two are the residue values. If I add up and if I solve this one, so this is the answer, and this is c. So c is nothing but the total contour. So we have two steps here, that is from integral z1 and z2. So this can be split into two parts, and as r tends to infinity, so if you substitute r is equal to, see here, if you substitute z is equal to r into e power I theta, so this is cr into f of z dz value tends to 0 as r tends to infinity. So I have given a clarity in my previous videos. Please go through that one. So here, as the video is very lengthy, so I'm straight away writing as 0. And this one here is, so e power I theta can be written as cos theta plus I sin theta. So if I multiply and equating the imaginary part, this is I and this is I. So if I equate these two, so I'll be getting pi by 4. So the result from minus infinity to plus infinity is same as 2 times of 0 to infinity. I'm sending 2 to other side, and this is a final answer, and this is a general formula. See here, this is how we have to solve. Hope you guys understand. Please avail this opportunity. Go through the playlist, check all the videos which I have uploaded. They'll be very useful. Those are all the previous questions in the question paper. So your preparation will be damn easy if you follow the playlist. Please pass it on to your friends, siblings, and whomever you like the most. Thank you so much.